Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 4, Lesson 8. Let's get started. Well, our question here is, can this equation be solved? Well, it looks daunting. But let's look at a quick example first. Let's say we had x, switch your pen, x over 5 is equal to 6 over 12. Let's say we had that equation. It's similar, right? It's a proportion, really. If you think back to 6th grade, we learned about proportions. It's this top expression compared to the bottom expression, and then an equal proportion with a top and a bottom, or numerator and denominator. So it's the same thing. It's a proportion. X over 5 equals 6 over 12. And then we had ways back in 6th grade to figure out what these are, but now we're going to use some algebra. I just want to remind you of what we did in 6th grade. We found a constant, right? We said, well, I know I can divide by 2. So 12 divided by 2 is equal to 6. So that means 5 divided by 2 must be my answer. So it looks like we could do it that way. That's how we did it back before we knew algebra. But now let's use some algebra to solve this, and that will give us an idea of how we can go about solving the more complicated one to the right. Well, look, I'm just trying to isolate that x, right? I'm trying to get that all by itself. So there's a coefficient of 1 in front of that x, so if I multiply by the reciprocal, that would be 5 over 1. And if I do that over here on the other side to balance my equation, I get my 5's to cancel, my 1's will cancel, I get x equals, and then on the right side, 6 times 5 is 30 over 12. So 30 divided by 12, and if we simplify that, 6 goes into both. 6 goes into 30 5 times, and 6 goes into 12 2 times. That's 5 halves, or 2.5, 2.5, which would be half of 12. And that's what we figured it would be, but that's how we can do it, right? That's a way that we can solve, is just by multiplying by the reciprocal to clear the denominator. But there is a shortcut, which I think you'll be happy to know. If we had, let's say we had a over b is equal to c over d. If we had two fractions equal to each other, a proportion or a ratio, we can say that that what's always true is this: a times d will be equal to b times c. And we call this means extremes, or if your parents are helping you, you'll probably hear them say, well, that's cross multiplying. Well, that's what we used to call it, but cross multiplying is kind of confusing, because we're really not multiplying these equations, but we're using multiplication to come up with an equivalent expression. So means extremes means the numerator of the first proportion times the denominator of the second will be equal to the denominator of the first times the numerator of the second. And it is cross, there's your cross part, and you are multiplying. A times d is AD, and if we go this way, b times c is BC, and they will be equal to each other. So in the example we had above, x over 5 equals 6 over 12. If we use means extremes, we would find x times 12 is 12x, and that's equal to 5 times 6, which is 30. And then if we multiply by reciprocal, then we get x equals 30 twelfths, which is what we had here as well. So you can use that theorem that says that a over b equals c over d. Then you can say a times d equals b times c. You can use that in our problem here. So that's what we're going to do. We're going to take this entire expression, 6 plus x, and we're going to multiply it by 8. So that's 8. Let me just write it out now. We'll simplify later. 8 times the quantity, 6 plus x. That's the means. And then extremes would be here. This would be is equal to 3 times the quantity, 7x plus 2/3. Okay, and then we can simplify and solve, and just like we did in the prior lessons. So I'm just going to use distributive property. 8 times 6 is 48, plus 8 times x is 8x, and that's equal to 3 times 7x, that's 21x, plus 3 times 2/3, that would be 6/3, and 6 divided by 3 is 2. And then get all of our variables on the same side. So subtract 8x, subtract 8x, and we get 48 is equal to 21 minus 8 is 13x plus 2. And then, again, we're trying to isolate that variable, so I'm going to subtract 2 from both sides. I get 46 is equal to 13x, and then we can multiply by reciprocal. And when we do that, the 13s will cancel. I get x equals 46 thirteenths, 46 over 13. And then we can simplify if possible, but for this one we can't. So this is it. They have no common factors, 46 and 13. So that's our answer. X is equal to 46 thirteenths. And that's a good answer. It's an improper fraction, but improper fractions are a lot easier to calculate with. If I need to use that number again, a lot easier to calculate with than trying to turn it into a mixed number, right? 13 goes into 46 3 times. 3 times 13 is 39. That means there's 7 left over. So we could say 3 and 7/13, but then I would have to calculate with that. And mixed number calculations are not fun. All right, so the answer is yes, we can do it. All right, so let's try it again on the next question. We're going to use means extremes again. So 7 times 8, that's 56, is equal to 1 times 3x plus 9 is just 3x plus 9. And then we can isolate our variables. Subtract 9 from both sides. 56 minus 9 is 47, is equal to 3x, and then multiply by reciprocal. And when we do that, the 3's cancel, we get x equals 47 thirds. 47 divided by 3 is 47 thirds. And I can't simplify that anymore, so that is our answer. Yes, x is equal to 47 thirds. All right. So, means extremes. Like I said, your parents will call it cross-multiplying. And that's kind of the name that was used, but it's a little misleading because we're really not multiplying these two fractions. We're not multiplying them together. They're equal to each other, but we are multiplying numerator times denominator in order to make this an equivalent fraction. So let's try this again. 6 times the quantity 2x plus 1. Notice these aren't in parentheses, but I'm making them parentheses because I need to multiply the 6 times this entire expression. And that's equal to 9 times the quantity 1 minus x. All right, and then we use the distributive property. 6 times 2x is 12x. Plus 6 times 1 is 6, equals 9 times 1, that's 9, minus 9 times x is 9x. And here we go. We're just getting all of our variables on the same side. That gives me 21x plus 6 is equal to 9. And then I'm going to isolate this variable. Subtract 6 from both sides. I get 21x equals 3, and then multiply by reciprocal. That's 1 over 21 times 1 over 21, and we get x equals, well, look, I like to simplify before I multiply if I can, and in this case we can. 3 goes into 3 once, 3 goes into 21 7 times, so my answer is 1/7. X equals 1/7. All right, so let's move on to number 2. Okay, same idea. Means is 7 times 5 plus 2x is equal to extremes, which is 6 times 3x minus 1. And when we multiply now with our distributive property, we get 7 times 5, that's 35, plus 7 times 2x is 14x, and that's equal to 6 times 3x is 18x, and 6 times a negative 1 is a negative 6. All right, let's get all of our variables on the same side. Subtract 14x from both sides. We get 35 is equal to 4x minus 6. And then we're isolating that variable, so I'm going to undo subtraction with addition. And we get 41 is equal to 4x. And then multiply by reciprocal. And we get, the 4's cancel, we get x equals 41/4. That's my answer. So, while these might look very complicated and confusing, how in the world am I going to do that? Using the theorem, means extremes, we can simplify and solve for those variables x. All right, let's try another one. 3 times the quantity x plus 9 is equal to 12 times the quantity negative 2x minus 1/2. Okay? Well, again, distributive property. 3 times x, that's 3x. 3 times 9 is a positive 27. That's equal to 12 times negative 2 is going to be a negative 24x. And then 12 times a negative 1/2, well, it's going to be negative, and half of 12 is 6. Okay, I've got a choice here. I don't like negative x value, so I'm going to add 24 to both sides so that we get a positive x value, positive 24x to both sides. We get 27x plus 27 is equal to negative 6. Now I subtract 27 from both sides, and that gives me a 27x is equal to a negative 33. And then I multiply by reciprocal, balance the equation, and we get x is equal to a negative 33/27. And that's as good as I can do, right? No, we can divide them by 3, or we can divide them both by 3. So this would be a negative 33 divided by 3 is 11, and 27 divided by 3 is 9. So a negative 11/9 is my final answer for x. Okay, let's do one more. Same idea here. 8 times the quantity 2x plus 1/4 is equal to 5 times the quantity 3 minus 4x. Okay, so we're going to use distributive property. 8 times 2x is 16x. 8 times 1/4 is 8/4. 8 divided by 4 is 2, so that's a plus 2 is equal to 5 times 3, that's 15. And then 5 times a negative 4 would be a negative 20x. All right, we're going to get all of our variables on the same side, so I'm going to add 20x to both sides. That gives me 36x plus 2 is equal to 15. And then isolate this variable, so subtract 2 from both sides. That gives me a 13 on the right side, a 36x on the left, and then I multiply by reciprocal. 1/36, and that gives us x equals 13 divided by 36 would be 13/36, and that is the value for All right, that is lesson 8. I hope that helps. See you again next time.